When we say that the universe is expanding, we mean that the distances between galaxies are increasing over time. Picture a loaf of raisin bread baking in an oven. As the bread dough expands, the raisins, representing galaxies, within it move away from each other. However, unlike the bread, the universe doesn't have a definite center or an edge. To understand this, we need to consider the idea of the observable universe. The observable universe is the portion of the entire universe that we can see or detect. Due to the finite speed of light, we can only observe objects that are within a certain distance from us. As light travels from distant galaxies, it takes time to reach us. The farther away a galaxy is, the longer its light takes to reach us. This means that our observable universe forms a sphere around us, with Earth at its center. The expansion of the universe is described by the Hubble's law, named after astronomer Edwin Hubble. Hubble's law states that the recessional velocity of a galaxy is directly proportional to its distance from us. In simpler terms, the farther a galaxy is from us, the faster it appears to be moving away. This observation is consistent with the concept of an expanding universe. However, it's crucial to note that this expansion is happening everywhere and in all directions. Imagine a balloon being inflated with dots drawn on its surface. As the balloon inflates, all the dots move away from each other. Similarly, in our universe, all galaxies are moving away from one another. But just as there isn't a single that serves as the center of the balloon's expansion, there isn't a specific point serving as the center of the universe's expansion. The cosmological principle is a guiding concept in modern cosmology that provides a framework for our understanding of the large-scale structure of the universe. It states that, when observed on a sufficiently large scale, the universe appears homogeneous, meaning it has the same properties at any given point, and isotropic, meaning it looks the same in all directions. Homogeneity means that the distribution of matter and energy is relatively uniform throughout the universe. It suggests that, on average, the universe looks the same regardless of where you are located within it. To support this notion, astronomers have conducted surveys of the distribution of galaxies on large scales and found that, when averaged over sufficiently large regions, the density of matter is relatively constant. This observation aligns with the cosmological principle. Isotropy refers to the uniformity of the universe when observed in any direction. In other words, the properties of the universe, such as its density and temperature, are the same regardless of the direction we look. One of the key pieces of evidence for isotropy comes from the study of the cosmic microwave background radiation, CMB. The CMB is the remnant radiation from the early stages of the universe, and it fills all of space. Measurements of the CMB have shown that its temperature is nearly uniform in all directions, with only tiny fluctuations. This remarkable isotropy of the CMB supports the idea that the universe appears the same from any location or perspective. By combining the notions of homogeneity and isotropy, the cosmological principle allows us to understand the universe as a vast, uniform, and isotropic entity without a defined center. It suggests that there are no preferred locations or special reference points within the universe. The cosmological principle forms a crucial pillar of our understanding of the universe's large-scale structure. It states that the universe appears the same from any location or perspective, exhibiting homogeneity and isotropy. Observations, including surveys of galaxy distributions and measurements of the cosmic microwave background radiation, support this principle by revealing a remarkable uniformity in the properties of the universe. This principle helps us comprehend that the absence of a center in the universe is a fundamental characteristic of its structure. The absence of a center in the universe, we now turn to the balloon analogy. This analogy offers a helpful visualization of the universe's expansion. To understand the balloon analogy, let's imagine a deflated balloon with dots drawn on its surface. As the balloon inflates, it expands in all directions, causing the dots to move away from each other. Now, let's consider an observer positioned on one of the dots. From their perspective, it appears as though all the other dots are moving away from them. However, if we were to ask an observer situated on any other, they would perceive the same phenomenon. In fact, every observer on any would observe the other dots moving away from them, leading to the illusion of being at the center of the expansion. This analogy helps us understand the expansion of our universe. Instead of dots, imagine galaxies spread throughout the fabric of space. As space itself expands, galaxies move away from each other, much like the dots on the balloon's surface. The expansion of space does not have a center, just as the balloon's expansion does not have a specific central point. It's essential to note that the balloon analogy is not a perfect representation of the universe's expansion. In the analogy, the balloon is expanding into the surrounding space, but the universe is expanding from within as space itself stretches. Additionally, the surface of the balloon is two-dimensional, whereas our universe exists in 3 dimensions. Nevertheless, the analogy serves as a useful visualization tool to grasp the absence of a center in the universe's expansion. While the universe itself is vast and expansive, the portion we can observe is limited. This limitation arises from the finite speed of light. As light from distant objects takes time to reach us, the farther away an object is, the longer its light takes to reach us. As a result, our observable universe forms a sphere around us, with Earth at its center. However, it's important to note that this does not imply Earth is the center of the entire universe. Instead, it signifies our observable region. The concept of the observable universe arises from the fact that information, including light, has a finite speed of propagation. Light travels at about 300,000 kilometers per second, 186,000 miles per second, in a vacuum. This finite speed means that the light we receive from distant objects has taken time to travel across space before reaching us. Consider a star located 1,000,000 light-years away. When we observe this star, we are seeing it as it was 1,000,000 years ago because the light it emitted 1,000,000 years ago has taken that long to reach us. If the star were to disappear or change dramatically in the present, we would not know about it until 1,000,000 years later. Now, let's apply this understanding to the entire universe. The universe is estimated to be around 13.8 billion years old since the time of the Big Bang. This means that the observable universe extends about 13.8 billion light-years in all directions. However, it's crucial to note that the universe itself is likely much larger than this observable region. The observable universe is like a sphere centered around us, with Earth at its center. It's important to understand that the observable universe is continually expanding. As time passes, light from more distant objects gradually reaches us, expanding the boundaries of our observable region. However, there will always be a limit to what we can observe due to the finite speed of light. Importantly, the fact that our observable universe has Earth at its center does not imply that Earth holds a privileged or central position within the entire universe. It is merely a consequence of our perspective as observers on Earth. From the standpoint of any other location in the universe, the observable universe would appear to have a different center. The concept of a center of the universe is a misconception stemming from our intuitive sense of spatial relationships. However, scientific evidence suggests that there is no privileged point or central location in the universe. The expansion of the universe, supported by the cosmological principle, demonstrates that every observer sees galaxies moving away from them, giving the illusion of a center. Nevertheless, the universe remains vast, homogeneous, and ever-expanding, without a defined center. Instead, the universe presents itself as a homogeneous, ever-expanding entity. Thank you for joining me on this cosmic journey today. Remember, our universe is a complex and awe-inspiring place, and unraveling its mysteries requires continuous exploration and scientific inquiry. If you enjoyed this video, don't forget to like and subscribe for more mind-expanding content. Until next time, keep looking up at the stars and questioning the universe around us.